Hello, okay, let's go through how we would answer the two questions in this story. I just combined them so I didn't have to try to shuffle pages. Now, when we have a word problem, the first thing we want to do is read through and pick out all the important information. This is math class, we're going to care about the numbers. We have a small town with a given population, and we're told how it changes. And then the second part is like, hey, how long does it take the town's population to hit a given thing that we want? So we're going to break this into two pieces. We're going to start by writing the function. Now, when we have an exponential function, every exponential function follows the form a times b to the x, where a is your initial value and b is your constant ratio. What we've discussed in class is outside of math class, the real world's change is not a whole number. For example, if this town's population was doubling, in a couple of years the town would completely break down because that type of growth is not sustainable. When a town is growing, we need all the civil services, so like the roads, the trash, the police, the firemen, and we can't keep up and keep those things if our population's doubling. Also, it's incredibly hard to double a population really quick. In a given town, there's young people, there's old people, like there's all sorts of things happening. So, what we've discovered or what we've noticed is that when this change is happening, it's not a whole number, it's a percent. So, instead of writing it as a times b to the x, we're going to keep a, but we're going to rewrite b. We're going to write it as 1, and then you have to decide if we add or subtract by the given percent. So that becomes a times 1 plus or minus r raised to the x. Part of what we'll do when we're writing this equation is we have to decide, based on what the story tells us, are we adding or subtracting? So before I go more into that, let's circle back to writing this equation. In my story, my initial value is 5,000. That is the starting point of this town. Then I'm going to find my constant ratio. The first thing I need to figure out is if this is a growth or decay. And if I read the story, it says it's growing. Neat. What that means is we're going to take 1 and we're adding our percent to this. Now, as review, the reason why we're using 1 is at 1, no change happens. We're not an exponential function, and this is actually how linear graphs grow. What we're going to do is we're going to convert that 5% into a decimal. We do that by taking 5 and dividing it by 100. And when I do that, I get 0.05. So I'm going to take that 0.05 and I'm going to add it to my 1. Now what's going to happen is we now have a growth factor. We now have a rate that's being constantly multiplied and it's above 1. It's not a lot above 1, but that's okay. And this is going to be our function. 5,000 times 1 plus 0.05 raised to the x. You can also write this as 5,000, and if I go ahead and add those two things together, I get 1.05 raised to the x. Either of these will work, either of these are acceptable. Again, all I did was I found my initial, I found my constant ratio, and for this problem, because it was a percent, I had to convert it. Now, the next piece is, when will my town's population break 30,000? There are faster ways to do this. There are more elegant ways to do this. However, to do that, we need to use different types of functions that we simply don't have access to right now, given our math understanding. And so what we're going to have to do is we're going to have to guess and check. So like I could start and I could guess, hey, you know what, 20. So on my calculator, what I do is I take 5,000. I type parenthesis 105 parenthesis raised to the 20. And when I do that, come on, I get 13,000. So then I would guess a bigger number. So if I guessed 50, I'd overshoot it, and then I'd have to keep guessing and checking until I found a closest value I could get. Now, the break point from when the town goes from below 30,000 to above 30,000 is between years 36 and 37. So what I could say, after 36 years. Because at 36 years, if my computer would act right, at 36 years, I have like 29,000 people, right? It's a little bit too low. 37 is a little bit too high. Just sometime after the 36th year, we will be over. If you want to be more accurate and say, oh, hey, after, 36 and a half years, like that is okay. We could also say 37 years. Because if we type 37 into our calculator, right, we would get 30,400. So it's almost the 37th year when the town goes from small to large. Make sure you're saying after, we would want this to be after 36. 36 is when it's too small, 37 is when it goes over. You could say or estimate or figure out like what decimal equivalent it is, but that's a level of detail I'm okay with you skipping. All this to say, this is how you can write the function. You find the initial and the change. When you have a percent, you convert the percent by dividing it by 1,000. We would answer a question about this by plugging numbers into our function, and then making sense for our answers. Otherwise, that's how we would solve this problem. If you still have questions, please be sure to reach out to me.